Okay, so I wanted to answer this question for you for about the standard deviation. So one thing you have to understand is basically what the standard deviation is talking about the spread of the data. So in this first image that you see, on the top information, you see that the standard deviation is 1.59. So basically, right here where the dashed line is, this guy right here, is your mean of the data. And what it's saying is that the average spread of the data is 1.5. That means that the average distance the data is from the mean is 1.59. Now you can kind of see the data for this one is pretty close together, centralized around the mean. You have a couple of pieces of data that are kind of out here to the sides, but most of it's fitting right here into that center portion of the data. Now look at the second graph. On the second graph, you can see that the standard deviation here is 2.79. And as you can see, again, here is my mean right here, this dashed line. And my data is much more spread out than the picture above. Again, remember that this is the distance from the mean, so you're saying that the average distance a data point is from the mean is 2.79. Now, obviously, we can compare these two particular pieces of data set because they're on the same number line, so you can visually look at it. Really, comparing two data sets is very difficult if they're not in the same measurement. We actually have in the next chapter, we're going to talk about standard scores and realigning data so that we can actually talk about two data sets at the same time. Now, what I wanted to also do is show you a picture. So I'm going to use this first data set. It looks like the mean of this data set, and I'm just eyeballing it, by the way, is 5. So we're going to use that as our mean. And then we're going to use our standard deviation as 1.59. So if I'm going to look at the picture, again, we're saying our mean is at 5. And what we're saying is that if I take this and I add the standard deviation, which is 1.59, that's going to get me here to 6.59. And if I subtract 1.59 from my mean, that's going to get me here to this guy right here. So 5 minus 1.59 is going to be 3.41. So the idea is that the vast majority, or 68% of my data, is between 3.41 and 6.59. Okay, I can do the same thing for two standard deviations. So two standard deviations means that I'm going to take, and I can start at the 6.59 or I can start back at the 5, whatever you want to do. I'm going to take this 6.59 because I'm going to do a little bit of cheating here. I'm going to add a standard deviation. So I'm going to add 1.59 to that. So when we do 6.59 plus 1.59, that's one more standard deviation, we get 8.18. And then we could do the same thing here, going backwards, subtracting 1.59. So we have 3.41, that's one standard deviation away. We're going to subtract 1.59, and we get 1.82. So now that means that between 1.82 and 8.18, that means 95% of our data lies somewhere between those two values, between 1.82 and 8.18. We can do this one more time. So again, I'm going to take this, I'm going to add 1.59 to it. That's going to give me a third standard deviation. Notice that I'm adding that same value. That's my standard deviation. So I'm going one more out. So 8.18 plus 1.59. That's going to get me here at 9.77. I'm going to do the same thing here, and we're going to subtract, again, the same standard deviation of 1.59. So we're going to subtract 1.82 minus 1.59, which should give us at 0.23. And if we look at this, from 0.23 to 9.77, 99.7% of our data lies between those two numbers. And it makes sense because look how far out we are. We're at the very, very tail end of each one of these. And you'll notice that right here in this picture, it's telling you that you only have 0.15% of your data that lies beyond those two numbers. Okay? And when we're doing studies or we're trying to figure out if something is significant, this is what we're asking. We're asking, what is the chances? So let's say that you did an experiment and you know that the population mean is 5, and your experiment, somebody got a 7.3. Well, your question becomes, is that far enough from the mean, the 5 of my mean, to say, hey, yeah, 7.3, that's significantly different from my mean? And we use our standard deviation to figure that out. So in this particular instance, if we're talking about 7.3, that's actually going to be more than 2 standard deviations away from our mean. Okay, and the chances of that happening is about 3%. So the question then becomes, is 3% enough to say, hey, yeah, this is significant. It went far enough away from my mean that I think that this is actually a possibility. This is actually something we might want to look at. That's what studying is all about, is to determine how far away something is from the mean compared to all of the other data. Is something far enough away from the mean that it's significant? Okay, and you have to do that by using both the mean and the standard deviation, or the average distance stuff is from the mean. So for this one, you can see with the 1.59, you've got these values here. But if I looked at the second one with 2.79 as a standard deviation, because my data is a lot more spread out, 7.3 might not be that significant because of the fact that the data is already very spread out. Whereas in the first example with the 1.59, since everything is kind of compacted onto that mean, it's very close to the mean, then 7.3 could be very significant because it is outside of what the norm is for that data. So really we're just kind of figuring out what's the normal thing for the data, what should it really look like, and then do things fall outside of that? And if things fall outside of that, is that important? So again, 1 standard deviation, that means that we're looking at about 68% of our data should fall within 1 standard deviation of our mean. And then for 2 standard deviations, we're looking at about 95% of our information, our data should fall within 2 standard deviations. And then for the last one, we're looking at 3 standard deviations, about 99.7% of our data. So the vast majority of our data should fall within 3 standard deviations of our mean. Okay, so if things start to fall outside of 3 standard deviations from our mean, then we ooh, that's probably important. And that can be important for 2 reasons. That could be an outlier. I'm going to talk more about outliers later. Or it could be that whatever experiment you did truly had a very big impact, and maybe we need to look at that again. Let me know if this helped as far as kind of explaining what standard deviation is and its relationship to the mean. If you need more explanation, just let me know.